Hello and welcome to Chapter 4, Exercise 13, Training Course Data Manager, Part 4. Okay, so far, we have covered the UI and signals on our flow journey from UI to server. We will continue that now with API requests and API handler, plus server.js and data manager for participants dataset. Recall from participant signals that it imports two signals from API service.js, get data, update data. All datasets share this API service.js and it's also used in the main Sizzle app. Let's look at this. Open API service.js, libAPI. Keep in mind the flow, UI signals-API- plus server.js data manager. We will skip the API request function for a moment. If you scroll down to the getData function first, you see that this is an async await, which calls the first function in API service.js, which is API request. Okay, back up to API request. Function API request is responsible for sending API requests to the server backend with the entity, e.g. participants, course, etc., the method, which is the HTTP method, get, post, put, and the data, which is optional and used for request body for post and put. The data is not needed for get nor delete. And because it's optional, place at the end with default null. Okay, let's break this function down to see what's really going on. We start with a dynamic URL using the entity pass to the function. In this case, from participant signals that would be trainer at participants, so the URL would be API trainer at participants. Next, we have object options, containing the method, passed to function as add or update. And if data exists and the method is not get, I'm not using delete, then we use that data as the body. Now we have a familiar async await to fetch the URL passing the options with try catch. So the fetch is sending out a request to where? To API trainer at participants plus server.js. Now, if you're unfamiliar with this, you may well ask, but where does the plus server.js come from? It's not in the code. Good point. Fetch is given the URL only, but fetch automatically targets the appropriate endpoint based on the URL provided. SvelteKit routing system automatically associates requests to the plus server.js file and depending on the method that was sent. This will automatically run the function for that method in the plus server.js file. Okay, so the await fetch sends the request, which is handled by the plus server.js and associated data manager, which we will cover shortly, and then the response is sent back. Then we await the response in JSON format, and as the .json itself is an async operation, that's why we need that second await. If the response is not successful, we get an error thrown, and either way, the results are returned to the calling signals function. And that's the main aspect of the API service.js file, to send those HTTP requests to the URL appropriate to your dataset and wait for a response from the server. Now, scroll down a little to the getData function that we left to look at the API request function. We now have the result, and this returns result.data back to the calling function in signals. Next, the update data function. This is also called from signals, but note here, unlike getData, we are not awaiting the API request, but instead just returning the call to the API request. So what we are returning here is not data, but a promise, as the request has not yet been fulfilled. Why the difference? Good question. getData needs the response immediately before continuing, so it awaits and always returns usable data. Update data does not need the response immediately, so it just starts the request, which means it returns a promise, not actual data. This leaves the caller, e.g. update participant, to await the result. A note here on the clean data. If data comes from a reactive state, e.g. $state, it may well be wrapped in a proxy or reactive reference, so converting to JSON and back ensures this is a pure object. Next function delData, not used. Decided instead to do soft deletes, which is an update to the flag field. The remaining functions are used elsewhere in the app and are not relevant to this exercise. Okay, so that's the API serves.js, which is shared by all the datasets. Next, open the plus server.js associated with participants. Where will this be? Correct! In the root for participant, so in /root/API/trainer/participant folder, and bear in mind that each plus server.js file is pretty similar, just working on a different dataset which may have different logic. Note that we import some functions from the data manager, which does the actual file fetches and updates to the JSON files. Next, we have functions for get, post and put, no delete, as I am not doing hard deletes. Bear in mind that we are now on the server side. SvelteKit routes requests to the corresponding plus server.js file based on the URL, as we saw earlier. The plus server.js responds to HTTP requests by running the appropriate function. So, if the request has a post method, then SvelteKit will automatically run the post function in the plus server.js file. As you can see, these are async await functions using try, catch. API request handlers. Get, this function fetches all participant data from the data manager and returns it as a JSON response. Post, this function receives new participant data, saves it via the data manager, generates an ID, and returns success with the new ID. Put, this function receives updated participant data, updates the existing record via the data manager, and returns a success response. Quick note on the post, that this is generating a server-side ID. You could do this client-side, but you run more of a risk of duplication because each person has their own instance of the signal and an update by one user would not change another signal. Ideally, this would be done with a database, not JSON. This is a deeper dive topic for later. Okay, so that's all I am going to say on the plus server.js file, except to say that you can expect the other dataset plus server.js files to be very similar. And we have one last step for the flow before it turns back to whence it came, and that is the data manager, which the plus server.js file loaded functions from. Next, open participant data manager.js, root /API/trainer/participant. Here is where the physical access of the data files takes place. We import promises and path, which are Node.js modules for handling files, and paths for file system promises, which allow you to await fd.read file and provides async operations. We specify here the path to the JSON file in the root for the participant.json. A familiar async await now at the file system level for fetching data. Next, another async await for saving data. You can see the ID being created. This is used by the post request, post equals add, and add requires new ID. And finally, a very similar function for the update, used by the put request. And with that, we have come to the end of the data flow, or have we? No, not quite, as the tide comes in, so it must go out. So, the flow must now make its way back from whence it started. Briefly, that's data manager back to API handler back to API request back to signals to UI. Here is an example data flow for adding a participant. Data flow recap, add a participant. 1. UI, user clicks Add Participant button after filling in the form which calls the signals function. 2. Signals, this sends the API request, he data and action, in this case, add. 3. API request, the sends a post request as action is an add to endpoint API trainer participants. For API handler, the plus server.js, the API handler receives the request and runs the appropriate function, in this case post, and calls the data manager. 5. Data manager, since we are adding a new record, a new ID is assigned, the data file is physically updated, and the ID is returned. 6. API handler, the plus server.js responds with the message, participant added, ID, new ID. 7. Signals, the local state updates, sorting is applied, and an alert is triggered. 8. UI, the new participant appears in the list. Okay, and that was quite a journey, and you may well be wondering why all those steps. To answer that, this goes back to the initial planning and decision-making process where we consider not only the user-client requirements, but also separation of concerns, UI, state management, API requests, server logic, and data storage are distinct. Security, server-side ID generation prevents duplication and manipulation. Scalability, API structure allows switching from JSON to a database with minimal changes. Consistency, centralized state ensures UI updates correctly after API responses. Reliability, the server, not the client, controls data integrity and prevents conflicts. Maintainability, each layer has a clear role, making debugging and modifications easier. Flexibility, the same API can serve multiple frontends or external integrations. What's next? Well, we have 3 more datasets: trainers, courses, and schedules. But before you despair, what you have covered for participants is almost identical to the other datasets, other than names and a little logic. So, we will zip through these and I will highlight anything significantly different. And that will be in the next video. See you there.